Okay, time to start. First video, log on fun in IT. I hope you enjoy it. It will be about SSD integration with of Linux and the Active Directory domains. I wrote an article about it a few months ago, and then I received some feedback that it was, too much focus in the code analysis, and this one is going to be like a simple explanation of the algorithms used and so really what are the options we have for this kind of integration. And the simplest one is simply add Unix attributes to AD. You can store user identifier, group identifiers in Active Directory, and potentially other attributes like home, like gigas. And if you add all those attributes, you even can just forget about the AD schema and think about your Active Directory as simply being an LDAP LDAP server. But this may not be an option if you're in kind of Linux, Windows focused environment where you have a lot of Windows servers, and the AD setup may be that complicated that no one will agree to add user identifiers, group identifiers to ADs just because you have a few Linux machines there. So in this case, you just have to use kind of mapping from security identifier to Unix attributes. And yes, it's possible. So let's compare what is security identifier, SID, and what is user identifier. Okay, so SID simply looks like this. It starts from S, then we have one, which is revision of security identifier. I've seen only the number one here, so probably only one revision up to now in Microsoft AED explanation. Then you will see mainly 5. It's a number that refers to the authority providing the security identifier. 5 means that it's coming from domain. Then we have a par specific for domain. So if it was 5 in the third field, then you have a domain identifier unique for the domain, and then you have so-called relative identifier, which is a 4-byte number specific for your user or group. Okay, and yeah, as you may know, Unix identifiers are also 4-byte numbers, so it looks like something similar, but you may also know that some of the UIDs are reserved for system users, and it's from 0 to 1000. It was different previously, and it differs between some old distributions, but for the modern distros, it's mainly like this. And guess what? Relative identifiers are also for normal users starts from 1000, so it looks like we have a perfect match, and we can simply use a relative identifier as user identifier, which is the concept that was used by old WinBind service, and you can enable such a behavior with sssd using the parameter I just mentioned, this auto-read compat, just provide the compatibility with WinBind daemon I mentioned. But it may be that this is not your case, that maybe you cannot spend all the UIDs for the Active Directory domain, or maybe you have multiple domains, maybe something was reserved. So normally your life is not that easy. In this case, you may be in a situation where you have to integrate, for example, with 2 domains, and you can only use some set of user identifiers from minimum to maximum. And it's also possible. And this minimum and maximum identifiers is really something you can configure in sssd. The another parameter, which is kind of important, is the range size. And range size is simply used to split all the domains and your UIDs, your range available for UIDs into some slices like this. And yeah, let's just discuss how it works, what will happen if someone will try to check the user, like here. We check a user with a specific user relative identifier. The user is in second range. So what will sssd do? It will look for the first relative identifier in this range and then create so-called slice name. I'm using some names just following the variables names from sssd code. So this is called slice name, and then it will use slice name to simply check which range on the UID side should be used. And it will use Marmor hash algorithm. Marmor comes from multiply, rotate. It's a non-cryptographic hash algorithm. You can check on Wikipedia. What does it mean, and then it will simply use modulo to have a number of the UID range to use. And after that, it will calculate your UID as the first UID plus relative identifier minus first relative identifier of the range, and it will assign this range. So the slice name is now assigned to the range number X, and in our case it will be 2. And this range on the UID side is simply allocated to the UIDs from the first to the last UID of the second range of this range on domain 2. So if we will have a lookup for another user that will simply be in this range, it will go into the second range of our UIDs. But what will happen if we have a collision here? Yeah, just the same UID range was selected. And it of course may happen because it's not something provided by murmur hash, which is kind of good hashing algorithm providing very random replies. But if you have a small number of ranges on unit side, then the collision may happen just because you're doing modulo 2 or modulo 3, something like this. Okay, in this case, SSD will simply try next range. So what it means, it means that unit assignments will depend on the order of system calls like get VW name. And this may be really an issue, and how to configure it properly to reduce the probability of such a situation. I will try to discuss with you in next article or video blog. Thank you for watching.